So here's a graph of the velocity function. F of t equals 160 minus 9.8 t. But we'd like to estimate the area under the curve on the interval from 0 to 3 so that we can estimate the distance that the projectile travels. Now, you asked the question, if we use left-hand endpoints, are we not including 3 seconds? And if we use right-hand endpoints, are we not including 0 seconds? Well, the truth is that, yes, we are including them. It's just understanding what we are using those endpoints for. So we're using those endpoints to help calculate the height of these rectangles. There's going to be 3 rectangles no matter whether you use left-hand or right-hand endpoints. And let me go to Desmos, share my screen, and show you what I mean. Here's where I got that picture. And just so you can see what I've done here, there's the graph of the function, 160 minus 9.8x. I enable it. Still, I get the same graph as showing elsewhere. Left-hand endpoint, a equals 0. Right-hand endpoint, b equals 3. Number of rectangles or intervals is 3. And when this c is 0, I'm using left-hand endpoint. See, that's the height of this rectangle. First rectangle at 0. The height of the second rectangle is using the 1 and the 2. Now, if I go this way and use right-hand endpoints, there's still 3 rectangles. It's just that each one has a width of 1, but the height they're calculated differently. And if I use the midpoint of each subinterval, I'll get a different approximation. This guy right here is the actual exact area under that curve, which we could get, by the way, geometrically, because this figure is actually a trapezoid. So if we wanted to, we could actually say, hey, I'm going to calculate the area under this, or I'm going to calculate the area of this trapezoid. And that would be 1/2 the height times the sum of the 2 bases. And these 2 parallel lines at f of 0 and f of 3 are the lengths of the 2 bases, and the height would be 3. Okay, so hope that gives you an idea of what's going on here. If you have any questions, post a comment.